everybody. Good afternoon and thank you for coming. My name is Óscar Bartolomé and now I'm going to present my project for the Analytics Cup, Dynamic Skills Finder. So what is Dynamic Skills Finder? It represents an end-to-end football data analytics project built entirely using open source technologies. Its primary goal is to facilitate and speed up the search for tactical parents and support player scouting using skill corners, tracking and dynamic events data. Let's take a deeper look. So here's an overview of the project's architecture. As you can see in this diagram, it consists of two main components. The first one is a complete ELT pipeline. It starts extracting open data from SkillCorner's GitHub repository. This data then is processed using a Python Polars pipeline. And finally, it is stored in a Delta Lake-based data lakehouse. The second main component is a web application built with RShiny for data visualization and exploration. So let's see more about these two components. From the ELT pipeline side, I would like to highlight how the data is structured, how it is stored. For that, I've implemented the medallion architecture. Well, the word medallion might sound like something grand, but it's just a commercial name for an approach to organize our data lakehouse, very similar to the traditional business intelligence design patterns. It consists of three main layers: bronze, silver, and gold. It can be implemented using different technologies. I've chosen Data Lake because of some of its advantages. The first one is that it creates a changelog that lets you roll back to any previous data version. The data is stored in data tables that are like Parquet files, but with full update, insert, and upsert capabilities. Also, it can integrate with tools like Unity Catalog for data governance. And of course, it's fully compatible with Polars. So now let's see the aim of each of these layers. The bronze layer is our landing zone. Here we store the data in its raw original form without any type of transformation or schema enforcement. Then this raw data is stored in the it's clean, it's transformed and modeled in the silver layer, and here's where we have our core data architecture. I've previously worked with SkillCorner's tracking data, but not with dynamic events data, so for me it's been a real challenge. I spent almost 3 weeks just to understand and model the final design. And specifically, I built an star schema with its fact tables and dimension tables. So let's see in detail. Okay, as you can see here, it consists of 3 main central fact tables. The first one, fact player match, that contains 1 row per player and match, detailing minutes played, goals, cards, all match-specific stats. Fact tracking, as its name implies, it stores all the tracking data. And the same for fact dynamic events table that stores our data in the dynamic event data files. Surrounding these 3 fact tables, we have the dimension or lookup tables. They contain the descriptive context for competitions, players, teams, matches, and they allow us to filter and group the data in the fact tables efficiently. And finally, we have the gold layer. This layer is the source that feeds the app. It features 2 types of tables. The first one, ready-to-use views. They contain tracking or dynamic events data combined with the principal attributes from the dimension tables. And this eliminates the need for performing complex dynamic joins that can slow down the app's performance. The other type of tables are aggregate tables. This table contains aggregated metrics at player or team level, and this prevents the app to perform costly aggregations on the fly. On the web application component, I would like to talk about that it is being created using rShiny and following our package code structure and principles for better reusability, maintainability, and shareability. All the visualizations within the app have been crafted using ggplot2 package and enhanced with interactivity using gggraph package. It is organized in two main modules, the tactical analysis module and the scouting player module. And both of these modules have its own comparison tool. Okay, also I know that every insight we find in the data must be validated on the pitch. So for each dynamic event we find in the data, we can immediately watch its video moment. Okay, before we see the app in actions, I would like to highlight some technical features that make this platform powerful. And the first one is the velocity. On the ELT side, for every data transformation or metric creation, I've used Python polars. Python polars leverages parallel processing and lazy evaluation that help us to maximize processing speed and optimize memory use. We tend to think that we need larger things like Spark for everything, but there are tons of workloads that don't necessarily need a whole Spark cluster and each added cost of Databricks for solving the problem. On the web app side, I've used Apache Arrow for every dynamic filtering and data operations. Apache Arrow let do this on memory. It's very similar to Polars. I think, in fact, that Polars is built on top of Arrow. And beyond the final submission, I've implemented asynchronous programming for the dynamic filtering. So this ensures that even when there are multiple concurrent users, the app remains smooth and responsive. And beyond the velocity, the platform focuses on user experience and exploratory power. For this, I've implemented some custom controls like the pitch zone selector or the dynamic filters that makes easy to search and makes it really intuitive to search within the app. Also, for the visualizations, I've followed the principle so more with less. Every plot in the app is interactive, and this allows the app to present clear and focused charts and letting the user drill down into detail on demand. So now, yes, let's see the app in action. Okay, let's start in the tactical analysis module. As you can see, the interface is divided, filters on the left, visualizations on the right. So for this example, let's set up a scenario. Imagine we have to analyze our next opponent, and it is going to be Melbourne City, the champions for that season. And as you can see, we have only 2 matches for analyzing. That's a very small sample, but let's see what we can discover. Particularly, we are a team that has some tactical principles, and one of it is that we press really high starting on opponent's build-up. So let's select that phase. Also, we want to analyze situations where their goalkeeper or their center backs have the ball on these zones. And more specifically, we want to see if their fullbacks come inside to more center positions to support build-up in a more inverted fullback role. So if we run this query, we see that we get two situations that we can analyze individually. If we click one of them, for example this, we get a full tracking data view. And look at this. Here we have a situation that when the goalkeeper has the ball, it's the left center back who is in a wide position, and it's the left back who comes inside to offer a passing option. We can validate this situation on video, so let's see it. Here we have this video moment, and if we see it again, and we stop here, we can validate that here is the goalkeeper who is going to receive the ball. The left center back is in a wider position, and here we have the left back that is going to offer a passing option in a more center position. We also can check the opposite pattern. Instead of fullbacks coming to this position, we can check fullbacks going back from these positions. And if we run this query, we get some more situations we can analyze individually. Also, if we don't like this type of charts with so many arrows, we can see it as heat map. And this is a small example of the power of the tactical analysis module using custom controls like these pitch zone selectors combined with these other type of filters. Analysts can translate or convert tactical questions into data queries. Okay, let's see now the scouting module. The interface is similar, filters on the left, outputs on the right. Let's set up another scenario for this example. Imagine we are a team that is very proud and happy with our main striker, but he is 36, and we know that we'll need to find a replacement for him soon. So let's scout for a center forward. We want the new player to be with us a lot of years, so let's scout for a player that is 27, if I can, 27 or less, and also that has played at least 90 minutes. Okay, and now we have our current striker has some skills that we want the new one to cover. So how can do with this? For example, we want that our new striker makes at least 5 runs in behind per 90. So here, if we click here, we can create a filter just for that, and we look for that metric. And now we have a custom control here for filtering that metric. So let's set up it to 5. Also, we want that this runs at least the 33% is target. So let's set up 2. And finally, the other skill we want to analyze is the counter pressures per 90s. That at least must be 5 also. So here we have just created a filter for everything we need, leaving a filter panel zone very clean and focused on what we need. So let's apply this query. And we get, as a result, a detailed table with the values for that metrics, and also another information from the player that we can hide if we want to focus only on these metrics. And also, if we click on any player, for example, Russ from Western United, we get a personal info overview from the player, and also a percentile chart comparing this player for that metrics with other players from the same league and position. And finally, let's check the comparison tool. If we select the comparison tool from tactic analysis module, we can compare teams. If we select the scouting one, we compare players. Let's try this one, for example. Here, as a result, we are going to get a custom scatter plot. We can select a metric for the axis and another metric for the dot size. So let's try with the same metrics of the previous example. Behind runs per 90, counter pressure per 90s, and as dot size, we are going to set the behind run started percentage. Let's set up also the same filters. And if we apply this, we get a custom scatter plot that is interactive. Also, we can label the outliers. And as you can see, we get again Rush from Western United. It seems to be a player like that outstands for that metrics. So, okay, this is a quick overview of what we can do with Dynamic Skill Finder. Let's come back to the presentation because I want to share my final thoughts. Okay. So the first one is I want to tell you my idea for contributing to the open source ecosystem. And it is that using the main features of this project, I want to create an R package containing functions for processing and visualizing tracking and dynamic events data, and also some custom controls for R-Shiny, like the pitch zone selectors, for example. And as final thought, I want to share that with a solid data architecture, plus fast velocity, plus user-focused customization and interactivity, we get the formula for building successful football data analytic tools, and this can be achieved using only open source technologies. Thank you.